Graphing a cubic function, number 21, we've got y equals x plus 2 to the third power. We're asked to state the coordinates of the vertex or point of inflection and then make a table and then draw the graph. Alright, so if we're dealing with a cubic function, that means we're thinking about the point of inflection. Alright, and that's, well, when I draw the graph, I think maybe I'll be able to explain what it is a little bit better. But the way that you find it out is you look at just what's in the parentheses first. Alright, so inside the parentheses, I've got x plus 2. And I want to ask the question, okay, what would make that equal, what would I put in for x to make that expression equal 0? And the answer is, it would be negative 2, right? Negative 2 plus 2 is 0. And so that's the first point in the table that I want to figure out, is that inflection point. And I'm going to draw it down here. I'm going to put my negative 2 down here because I can go in either direction, which I will want to do. I want to kind of put that inflection point in the middle. And when you put in negative 2, okay, negative 2 plus 2 is 0. 0 to the third power is still 0. So that point is going to be negative 2, 0. Now to get an accurate graph, now I want to get some points to the right and left of this inflection point. They said I only needed 4, but I might do 5. I'm feeling adventurous. Okay, so if I put in negative 3 here, negative 3 plus 2 is a negative 1. Negative 1 to the third power is still negative 1. Right? Negative 1 times negative 1 times negative 1, still going to be negative 1. Okay, so let's do negative 4. Let's do one more in that direction. Negative 4 plus 2 is negative 2. Negative 2 to the third power, negative 8. So you can see the numbers are rapidly going down there in that direction. Alright, so let's do some more in the other direction, going up. So negative 1 plus 2 is positive 1. Positive 1 cubed is positive 1. And we'll do one more. We'll do 0. And 0 plus 2 is 2. 2 to the third power is 8. So you'll notice it's not perfectly symmetrical, but you can see a pattern here, hopefully, right? The only difference is the 1 and the 8 here are positive, and then I've got a negative 1, negative 8 there. Anyway, when we're graphing the graph, you should start with either the vertex or the inflection point. So there's my inflection point. That was the first point I figured out, and that's where I'm going to start my graph. So there's the origin right there. Negative 2, 0 is going to be 2 to the left, up 0. There's negative 2, 0. And then I've got negative 3, negative 1, so that's right there. And then I've got negative 4, negative 8. So here at minus 4, I'm going to go down 8 points. I'm trying to make sure I do this correctly. I think I got it. All right, and now we'll graph these guys right here. So I have negative 1, 1. And I'm just plotting points right now, right? That's all I'm doing is plotting these points. And 0, 8. So there's my 0, 0 point. I go up 8, draw the dot. Now, for these graphs, you don't want to use rulers to connect the dots because they are curved graphs. So I'm just going to the best of my ability, draw a curve through those points. Didn't do a great job right there, but we're going to call that good enough. And again, notice this inflection point right here. It's the graph is kind of curving like this right up until the inflection point. It's kind of a frowny face shape, and then right at that inflection point it goes from being a frowny face to a smiley face. Those are technical math terms, by the way, if you didn't know that. Frowny face and smiley face. That's what an inflection point does. You're going from frowny to smiley or smiley to frowny. But that's important. That's an important point to know because that's when that transition happens. All right. One more. This one is a quadratic function because we're just taking this to the second power, not the third. So these functions are, they're U-shaped, and it's either a right side up U or an upside down U. All right? They're parabolas. And what we're going to do for any parabola, just like with the cubic function, well, the cubic function we start with what's called the inflection point. Parabolas don't have inflection points. They have vertices, or they have a vertex, okay? Same concept, though. I want to find that vertex because that's going to be either the bottom or the top of the parabola. I look at that right there, and I just ask the question, what would make x minus 4, what would I put in for x to make x minus 4 equal to 0? And the answer is 4, right? 4 minus 4 is 0. So when I'm making my table, that's the x that I'm going to start with because, again, that's going to give me the bottom or the top of the parabola. All right, so I'm going to start at 4. When I plug in 4 to this, okay, 4 minus 4 is 0. 0 squared is 0. 0 plus 1 is 1. So there's the vertex. And because this is positive, it's going to be a smiley face, and that's going to be the bottom of the graph right there. So I want to do a few more points on other sides. So I'll say, 3. 3 minus 4 is negative 1, but negative 1 squared is positive 1. Plus 1 is 2. And then I'll do one more. 2 minus 4 is negative 2. Negative 2 squared is positive 4. Plus 1 is 5. And now we can go the other direction. I put in a 5. 5 minus 4 is 1, but 1 squared is still 1, and 1 plus 1 is 2. And then the last one we'll do is 6. 6 minus 4 is 2. 2 squared is 4. 4 plus 1 is 5. Now notice, unlike the cubic function here, I don't know why I drew a little line right there. I shouldn't have that. Anyway. These are symmetrical, right? Like you can see the symmetry on either side of the 1. 1, 2, 5, 1, 2, 5. And if we kept going, that same symmetry would continue. That's why they call these even functions. Okay. Anyway, when we're graphing, again, start with the vertex. If you've got a parabola. If you've got a cubic function, start with the inflection point. If you've got a parabola, start with the vertex. 4, 1. Okay, so I'm going to go over 4. Now let's see. And then up 1. And again, I know that that's the bottom of my graph right there. And so I can graph these other points now. We've got 3, 2. So there's 3, 2. You've got 2, 5. And then I'm going to have the same points on the other side. 5, 2, 6, 5. Again, we don't use a ruler for these because they are curves. So to the best of your ability, you draw that smiley face that goes through the points. And there is our happy parabola.